Hello and welcome to our lesson on understanding how to measure the spread of our dataset. Today, we'll explore some essential concepts that will help you analyze and interpret data more effectively. In this lesson, our primary focus will be on understanding the range of values within a dataset and determining what to do with this information. We'll start by defining the range and learn how to calculate it. Then we'll discuss why the range is important in analyzing data. After that, we will move on to some practical examples to apply this new knowledge and solidify our understanding. In our previous lessons, we've developed a strong foundation by discussing data terminology like population, sample, discrete, and continuous data, and primary and secondary data. We also learned how to group and organize data for better understanding and analysis. Furthermore, we examined various ways to display data, including frequency tables, time series graphs, pictograms, bar charts, histograms, pie charts, scatter graphs, and cumulative frequency graphs. And we explored how to calculate the mean, median, and mode of a dataset. With this foundation, we can now explore the concept of the range, which is a measure of how spread out the values in a dataset are. Understanding the range is crucial in comparing different datasets and providing insights into the variability of the data. Let's dive into the new technique for today's lesson, understanding how to measure the spread of our dataset. First, let's define the range. The range is a measure of how spread out the values in a dataset are. Specifically, it is calculated as the difference between the highest and lowest values in the dataset. Mathematically, it can be expressed as range equals maximum value minus the minimum value. For instance, if we have a dataset of test scores, 56, 67, 89, 92, and 100, the range would be calculated as the highest value minus the lowest value. So in this case, it would be 100 minus 56, which equals 44. Be careful when the dataset involves negative numbers. For instance, if we have temperatures minus 10, minus 14, minus 2, and minus 4, the range would be from minus 2 to minus 14, which is 12. The range provides a quick snapshot of the data's variability. If the range is large, it indicates that the data is spread out widely. If the range is small, the data is closely clustered. However, the range has a limitation. It is sensitive to outliers. An outlier is a value that is significantly higher or lower than the other values in the dataset. For example, if our dataset includes an extremely high or low test score due to a mistake or exceptional performance, the range would be disproportionately large, which might not accurately represent the rest of the data. To address this issue, we introduce another measure called the interquartile range, or IQR. We have actually already seen this in our previous lesson on cumulative frequency diagrams, but we will reintroduce it here. The IQR focuses on the spread of the middle 50% of the data, thus giving us a better understanding of the central tendency and reducing the impact of outliers. To calculate the IQR, we need to identify the lower quartile, Q1, and the upper quartile, Q3. To do this, we arrange the data in ascending order, then identify the median, the middle value. If the number of data points is even, the median is the average of the two middle values. The lower quartile, Q1, is the median of the lower half of the data, excluding the overall median if the number of data points is odd. The upper quartile, Q3, is the median of the upper half of the data, excluding the overall median if the number of data points is odd. Finally, the IQR is calculated as follows: upper quartile minus the lower quartile. For example, consider the dataset 4, 7, 9, 12, 15, 18, 21, 24, and 28. The median is 15, making the lower half 4, 7, 9, and 12, and the upper half 18, 21, 24, and 28. We now need to find the median of the lower half, which is 8, the mean of 7 and 9. This is Q1. Let's do the same with our upper half to find Q3. The mean of 21 and 24 is 22.5, which is our Q3 value. Lastly, to find the IQR, we need to subtract Q1 from Q3. 22.5 minus 8 gives us an IQR of 14.5. A visual way to represent this data is using a box plot. A box plot, also known as a box and whisker plot, is a graphical representation of the dataset's distribution based on the 5-number summary: minimum, Q1, median, Q3, and maximum. To draw a box plot, first draw a number line that covers the range of the data. Then mark Q1, median, and Q3 on the number line. Next, draw a box from Q1 to Q3 with a line at the median. After this, draw whiskers from the box to the minimum and maximum values of the data. Any data points outside 1.5 times the IQR from Q1 or Q3 can be plotted as outliers. Remember to calculate the IQR, we do Q3 minus Q1. So in this case, we get 6.5 minus 2, which is 4.5. We multiply the IQR of 4.5 by 1.5 to get 6.75. We can now use this number to identify outliers. Any data points which are less than Q1 minus 6.75, which is minus 4.75, or greater than Q3 plus 6.75, which is 13.25, are classified as outliers. We can represent these on the box plot with a cross. In our case, there are no outliers in the dataset. We can also use a cumulative frequency, or CF graph, to find these quartiles visually. In a cumulative frequency graph, the cumulative frequency is plotted against the upper class boundaries of the dataset. To find Q1, locate the point where the cumulative frequency is 25% of the total frequency. Then, to find Q3, locate the point where the cumulative frequency is 75% of the total frequency. Draw horizontal lines from these points to the cumulative frequency curve and then down to the data values on the horizontal axis. By understanding and applying these techniques, we can more accurately describe and interpret the spread of our dataset, particularly when it contains outliers or irregularities. This knowledge is crucial for deeper data analysis and making informed decisions based on the data. Let's begin by examining a simple example to illustrate how to calculate the range. Consider the following set of test scores: 12, 15, 18, 20, and 22. First, identify the highest and lowest values in the dataset. Here, the highest value is 22 and the lowest value is 12. Next, subtract the lowest value from the highest value to find the range. Here, this is 22 minus 12, which equals 10. So the range of this dataset is 10. This tells us that the test scores vary by 10 points. Let's look at another example with a set of temperatures recorded over a week: 25, 27, 30, 29, 26, 28, and 31. As before, identify the highest and lowest values. This time, highest value is 31 and the lowest value is 25. Now let's calculate the range. 31 minus 25 equals 6. Therefore, the range of temperatures for the week is 6 degrees, indicating the spread of temperature readings. Now let's tackle a slightly more complex example involving grouped data. Look at the provided data, which shows the ages of participants in a survey. Even though the data is grouped, we can still calculate the range by considering the endpoints of the age groups. Let's identify the lowest and highest values in the entire dataset. The lowest value is the start of group 1, which is 10, and the highest value is the end of group 5, which is 34. Therefore, the range is 34 minus 10, which equals 24. The range of ages in this survey is 24 years, showing us how widely the ages of the participants vary. By walking through these examples, you can see that calculating the range involves straightforward subtraction, but it provides valuable insights into the spread of data. Remember, the range helps us understand the variability in our dataset, which is an essential aspect of data analysis. In today's lesson, we explored the concept of measuring the spread of a dataset, starting with the range. We defined the range as the difference between the highest and lowest values in a dataset, providing a simple measure of variability. However, we noted that the range can be sensitive to outliers, which may not accurately represent the overall data distribution. To address this, we introduced the interquartile range, which focuses on the middle 50% of the data, reducing the impact of outliers. We learned how to calculate the interquartile range by identifying the lower quartile, Q1, and upper quartile, Q3, and subtracting Q1 from Q3. We used a practical example to demonstrate these calculations and discussed the importance of using the IQR for a more robust measure of data spread. Additionally, we looked at box plots, which visually represent the data's distribution, including the range, quartiles, and potential outliers. We also touched on cumulative frequency graphs as another method to find quartiles. By understanding and applying these techniques, we can more accurately describe and interpret the variability within a dataset, which is crucial for effective data analysis and making informed decisions.